have to remember. And the strategies of automation. What is the automation? What are the different types of automation or levels of automation? What are the reasons to go for the automation? Then the last one is the strategies of automation. What are the strategies of automation? There are, I think, the 10 important points are there. Those 10 important points you have to remember. Kindly go, just remember them. I am going to explain. Specialization of operation. The specialization of operation in this, for a particular type of operation, we are going to have some kind of automation, and a specialized person will be left there. Okay, for example, thermal engineering subject will be handled by the thermal engineering teacher, so that the efficiency will be increased. He will be knowing the previously subject, and the students can easily understand. He can able to give more important evidential examples and all this. So like that, the specialized labors. The specialized labors can be used for the specific work, wherein the specialized work, a special type of machineries can be used. That is the specialization of operation. Combined operations. Combined operations. What is the meaning of combined operations? We are, for example, you take the lathe. We are going to do a lathe. I want to do a turning and the threading operation. I am going to do a turning and the threading operation. If I am going to do possibly the two operations in the two different lathes, one lathe will be always engaged in the turning operation, other lathe will be engaged in the threading operations. What happens once after completing this turning operation, the part have to be loaded and the turning have to be completed. It has to be unloaded and it has to be left and it has to be taken to the second lathe. Again, it has to be loaded. The turning operation have to, the thread operation have to be done. Instead of that, if I am going to combine these two operations in a single lathe, the turning in the similar setup, I am going to do the threading operation. That means today we are going to do the combining the operation. The combining the operation, a very simple example I given you. The different processes also can be taken into account. Here, the combined operation in the sense, here the number of workstations will be reduced. Instead of having the two different lathes, I am going to use the single lathe only. That means the number of machines will be reduced and the space consumed by the two machines, that means that also can be reduced. The space requirement for the machineries also can be reduced. Okay, and the non-operation time, waiting time, loading and unloading time, all these can be reduced because two times you are going to load the materials. In a single setup, we can do the two operations. That is called as the combined operations. Okay, simultaneous operations. It is one of the important logic. You can see that the simultaneous operation in the sense, while I'm going to do performing one operation, at the same time, other operation also can be done. Very simple example, I'm going to do a turning operation. I want to do the finishing operation by using the emery paper. Emery paper, I want to do the finishing operation. So here, while I'm performing the turning, the plain turning operation, I can do the emery operation. The two operations can be done simultaneously at a time. So combining the operation is different and simultaneous operation is different. Combining the operation is on a single station. We are going to do two different operations, one or the other. Here in this case, we are going to combine the two operations, but here simultaneously the two operations will be done. In a single working time, the two operations can be completed. That is called as the simultaneous operation. Integration of operations. Integration of operation in the sense of how the three different machines, they are working together and the part will be moving from first machine to the second to third, and final finished product will be coming out. But here what I am going to do is we are going to integrate these three or even 10 machines, 20 machines together. What happens? Integrating them, what happens? The work movement can be easily happened and the several operators in between or carriers in between can be reduced. Okay. So overall, the output of the industry will be increased. That is the integration of operation. Okay. The work holding devices and all these devices can be used. The manual involvement will be very less while the work is transferred from one machine to the other machine. In one machine, I am going to complete one operation. Then for the next operation, it will be shifted to next. And after completing that, again, it will be shifted to the next. Like that, the manual involvement can be reduced once you go for the integration of operations. All these will be integrated by means of a child conveyor or grades or something like, so that there will not be much more manual environment while transferring the work from one machine to the other machine. That is called as integration of operation. Then increased flexibility. Increased flexibility in the sense we can utilize the machineries to the maximum extent. As I told you here, the varieties of products can be done. So varieties of product can be achieved by doing small changes with the machine configuration or setup. All these can be done. So that can be done easily. So what happens here? We can flexibly increase the flexibility of operation. So all the equipments can be utilized to the maximum extent. So the output of the industry can be increased and there will be reduced in the manufacturing lead time. Okay. Then next one, improved material handling and storage. Improved material handling and storage. So here we can use the ASRS, automated retrieval and automated storage systems. And the work will be moving from one machine to the other machine by using the conveyors. So all this will be happening automatically. So the work handling and storage cannot be done by manual method, so that it will be improved in the material handling and storage in sense. Then it will be reduce the work in process and manufacturing lead time and the lower the labor cost, because the labor involvement will be very less. This is improved material handling and storage. Online inspection. It is one of the important sector, the online in process, online on process. Okay, these are the different inspections. As in case of CNC machines and all, in a lathe and CNC you take. In a lathe, what we do, the inspection will be done after the completion of the process. For example, I want to keep a 30 plus or minus 0.01. So by manually what the chaotic errors, we have been removed little more material, and what happens, it will not be within the tolerance, the material will be rejected in case of a lathe. If you go for the CNC operation, what happens, inbuilt testing methods will be there. The inspections will be done inbuilt. So here the errors will be very less and the rejections will be zero. So that means to say, online, while the work is under progress, the inspection will be done, and whatever the changes to be done within the machine itself, it will be done automatically. So the rejections will be very, very less or zero. That is what online inspection. Process control and optimization. Process control and optimization. The whole process can be optimized and controlled by using some of the computer-aided systems, so that the associated equipment can be giving you the efficient output. This is out. And another one, will be forming the other new or other area of improved quality product. The process control, whole process can be controlled. Okay, the entire the factory can be controlled by using the signal system, so that we can optimize the path of movement. Okay, so that the work movement can be effectively, and the manufacturing lead time can be reduced, work in process can be reduced, and the maximum utilization of the machineries and output of the industry will be very, very high. The process control and optimization. The next one, plant operation control. So the individual machine also can be controlled, and in turn integrating all these machines together, the whole plant, along with the account department, along with the managing department, along with the quality control department, along with the loading and unloading and the storage, everything can be automated together. So this is called the plant operation control. This is one level, higher level as compared to the previous one. Computer integrated manufacturing. Computer integrated manufacturing. The whole industry can be integrated together with the business sectors. Okay, and we can have the integration of these informations with other industries also, which is working in other country. So globally we can able to control all these systems by using the computer integrated manufacturing. That means to say, a person is sitting in America having the similar kind of company, he can able to control the manufacturing activities which is situated at India. This is how this is called as computer integrated manufacturing. So these are